Okay, so we're starting with x is equal to a sine omega t, v is equal to omega a cos omega t, and the question says a particle is moving in a straight line with SHM, the amplitude of the oscillation is 0.5 meters and p passes through the center of oscillation O with speed 2 meters per second. Calculate the period, calculate the speed when OP equals 0.2 meters. So looking at that question, if we start off with the speed being 2 when it passes through the center of oscillation, so at this point we can say when this is equal to 1, we can look at our maximum velocity is equal to a omega and v. Okay, so the maximum velocity is omega a. So using that the amplitude is 0.5 and the maximum velocity is 2, we can work out that omega is 4, very simply. Now, using the equation for omega is equal to 2 pi f, it's the angular frequency. So we can rearrange that to give us a period. Okay, so the period is equal to 2 pi over 4. Okay, where period and frequency are the inverse of each other. So that gives us that this that the period is 1.57 or pi over 2. So on to part B. If you use the prior information, okay, as in you use omega, then you can work out what the speed of p is when OP is equal to 0.2. So using that the distance is 0.2, we can calculate the time that it's at 0.2, and in doing that you can find that the time is at 0.103 seconds. So that can be substituted into the equation for velocity to give you the velocity at that point. Okay? Alternatively, what you can do is you can take that v squared is equal to omega squared a squared minus x squared. You can substitute in your values and you can get that omega is 4 and that the period is pi over 2, and then you can repeat again. Okay, you can repeat this process. You can say x is 0.2 meters and you can find the velocity, so v squared equals omega squared a squared minus x squared, and because we found the period in the last part, then we can just substitute our values in. So we get the velocity is 1.83 meters per second again. So 2 ways of answering the same question, one using one equation, one using the other. Okay, identical end result. And you can see the second way is probably considerably easier and shorter.